Okay, in the last video we said that our basic function for exponential functions, f of x equals a to the x, and we want to talk about transformations. We can also, of course, f of x is y, so you may see it written like this, same thing. We talked about how these 3 points are on this basic graph of every function. Whatever the base a might be, a has to be some number greater than 0, it has to be positive, and it cannot be 1. So now we want to look at some possible transformations that you might see. And let me get my list. Okay, so we might see something like y equals 2 to the negative x. Now how would we know what's going on here? Inside the function, that affects the x values. The negative has to happen before you raise the power. That means inside the function. That means it's a horizontal effect. It's affecting our x's. And it means we're going to reflect over the y. So that tells me multiply x by negative 1. What are the points that I have to work with? Well, I have negative 1, 1/2, 1 over a is 2. That point would transform by multiplying a by negative 1. Negative 1 times negative 1, my y does not change, so my new point would be positive 1, 1/2. This is what would happen. That point, if it reflected over the y-axis, which is what that means, it's now at the point 1, 1/2. Another point I know that's on the original function is 0, 1. If I multiply negative 1 times 0, y doesn't change. This point doesn't change, and that should make sense. This point is on the y-axis. I'm reflecting over the y-axis. Let me just write that. This means reflect over y-axis. If a point on the y-axis is reflected over the y-axis, it's still on the y-axis. The other point we know is 1, 2. Multiply x by negative 1. Y doesn't change. Negative 1, 2. So these are the new points on the graph. So you would be able to determine which graph, if you're matching or trying to match equations to points, this is how you can make that happen. So that's one example. Y equals 2 to the negative x. Let's look at another one. How about y equals negative 2 to the x? Okay, now we're outside the function. This means reflect over the x-axis. In other words, multiply y by negative 1. My 3 points are negative 1, 1/2. Now I multiply y by negative 1. New point is negative 1, negative 1/2. 0, 1. Multiply y by negative 1. New point, 0, negative 1. And 1, 2. Multiply y by negative 1. 1, negative 2. So it's important to know these 3 points. If our base was 5, it would be negative 1, 1/5, 0, 1, 1, and 5. Okay? This is our base here. If it was e, it'd be negative 1, 1 over e, 0, 1, and 1e. Of course, e is a little more difficult because it's an irrational number for looking at graphs anyway. All right, what if we had y equals negative 2 to the negative x? What's happening here? We're reflecting over both. Reflect over both x and y. And so both of those are multiplied by negative 1. In other words, the sign is going to change for both x and y. That's the easy way to think about it, because then I don't have to do all that multiplication. I just say change the signs. Of course, 0 doesn't get a sign. Okay, that would reflect over both. Just change the signs. multiply x by -1 and y by -1. All right, those are some reflections. Let's see what else we might could do. We could have y equals 2 to the x minus 1. Outside the function, we raise 2 to the x first. This affects the y down 1. Shift down 1. Okay, subtract 1 from y. That's how you'll shift down 1. Same 3 points, -1, 1/2. So it's -1, 1/2, minus 1, -1, -1/2. 0, 1, 0, 1 minus 1. Now we're at the origin, and 1, 2, 2 minus 1, and we're at 1, 1. Shifting the whole thing down 1. Now, you should sketch some of these graphs to see. I'm just trying to save time by not sketching them because I assume you can plot points. Plot the original points, then plot these points and see that the entire graph is shifted down. Or go back to the reflections and see how it flips over the y-axis, flips over the x-axis. You need to visualize this stuff. Okay, let's look at the difference between that and 2 to the x minus 1. Now recall, it's in the function now. That affects our x. And the tricky thing, this means shift right 1. Shift right 1, which means add 1 to x. So all of our x's, -1, 1/2. If I add 1 to -1, I now have 0, 1/2, 0, 1. 0 plus 1, 1 is at 1, 1, and 1, 2, 1 plus 1, and now we're at 2, 2. That's the entire original function now shifted to the right. Plot those and watch it move to the right. So we did our shifts, we did our reflections. Let's look at one. What if we saw something like this one? It might be a little tricky and we may not recognize what's going on. That looks odd. That's kind of the opposite. It looks not quite like what we just did. We have to use a little algebra here to understand what's going on. So I'm going to rewrite this as y equals 2 to the -1 times -1 plus x. I just factored out a -1. That would be 1 minus x. And then I'm going to just make that a negative because we don't have to write the -1. And addition is commutative, so I can switch their places, x plus -1, or in other words, x minus 1. Now we see two different transformations happening here. This means shift right 1. This means reflect over the y-axis. Okay, so we're going to, let's make a note, reflect over y-axis. That means multiply x by -1, and we're going to shift right 1, and that means add 1 to x. So we multiply before we add. So that's what's going to happen. We're going to take our original x value, we'll have our x and y, well, and we'll do these things. So what are our original points? Of course, as we've been going over these, we've got -1, 1/2. So I'm going to multiply x by -1, multiply x by -1, and then add 1. Nothing happens to y. And so what do we get? This makes +1. +1 plus 1 is 2. 2, 1/2. 0, 1. Multiply x by -1 and add 1. Well, of course, all that does is the add 1, right? So 1, 1/2, and 1, 2. Multiply x by -1 and add 1. Why am I writing 1/2 there? Sorry, that should be 1. And this shouldn't be 1/2. I'm getting in a bit of a hurry, aren't I? Okay, so this is 1, 1, and this would be Negative 1 plus 1 is 0, 2. Okay, so we've gone to 2 1/2, 1 1, and 0 2. This had 2 transformations in it, but we had to do a little bit of algebra to reveal them. There's one other one that's a little tricky like that I want to go over, and then we'll wrap this one up. And it looks like this. Y equals 1 minus 2 to the x. Again, we don't see that 2 to the x plus or minus something. We're not used to seeing the number first. So let's rewrite it then. Negative 2 to the x plus 1. This is positive, that's negative. We just rewrote it, and now we see this negative out here outside the function. Reflect over the x-axis, up 1. Reflect over x-axis, that means multiply y by negative 1 and shift up 1, that means add 1 to y. So this time it's all affecting our y values. So our points again, we have negative 1, 1/2. We're going to multiply, so x isn't changing, everything's affecting y. Multiply our y by negative 1, and then add 1. So we have negative 1, and this would be negative 1/2 plus 1, positive 1/2. 0, 1, 0, negative 1 times 1 plus 1, 0, that's going to be 0, the origin. And 1, 2, 1, negative 1 times 2 plus 1 gets us to 1, negative 1. Okay, so we had to do a little bit of algebra, just switching those, and all of a sudden we can see the transformations.